The next question. XML and YML of 0.1 molar HCl, different volumes of same molar HCl, are required for two separate titrations against a given sample of sodium bicarbonate using methyl orange and phenolphthalein respectively as the indicators. So the question is based on indicators. And you know that phenolphthalein is the indicator with pH range in basic medium. So in the titration of strong base like NaOH and strong acid like HCl, it can be used as an effective indicator. Also can be used in the titration of strong base, weak acid as an effective indicator because functions effectively in basic range. Whereas when we go for methyl orange MEOH as an indicator, it will be an effective one in acidic range. But in the titration of strong base against strong acid, as we know, acid base indicator can also be used. Therefore, methyl orange can be used as an indicator. But whereas it is effective in the titration of strong acid, weak base. So based on this, how do you work out this particular question? So here it is given is sodium bicarbonate, which is the salt of strong base and weak acid. It will be slightly basic. And you are titrating against HCl. In one titration, for the complete neutralization, XML of acid is required of same concentration 0.1 molar HCl. But whereas in the titration of sodium bicarbonate with HCl of same concentration of 0.1 molar, YML is required in the other titration. Here, if you are using phenolphthalein, let us check. XML and YML of 0.1 molar HCl are required for two separate titration against a sample of NaHCO3 using methyl orange first. So this is the methyl orange for which XML is required, and this is phenolphthalein indicator. Then, is the volumes consumed in both the titrations same, X and Y? Is the volume required in the first case is double to Y, as in this case, or no color change in titration using phenolphthalein? As we know that this is strong acid and this is weak base, the solution at the end point will be acidic in nature. So when the solution at the end point is acidic in nature, which is an effective indicator, methyl orange is an effective indicator. But here we are using methyl orange indicator, therefore this is appropriate. But whereas for the same titration we are using here phenolphthalein, and phenolphthalein functions effectively in basic range. But the solution here at the end point is acidic, so phenolphthalein cannot be used as an effective indicator at all. Thereby, as given in the option D, no color change in titration using phenolphthalein is obtained with the addition of one drop at the end point of the titration. So therefore, this titration cannot be carried out using phenolphthalein at all. Therefore, we cannot make any of these comparisons. And thereby, option D, no color change in titration using phenolphthalein is observed. And thereby, this titration cannot be carried out using phenolphthalein. Hence, the option D will be the appropriate answer.